This video recording is going to be a short review of formula writing and naming, as well as determining molar mass. The question might be something like, what's the formula and the molar mass of calcium carbonate? To be able to figure out this, you should figure out the two parts separately. First, the cation, which is the first thing mentioned, is the positive ion. And you simply go look on the periodic table. This is calcium. It's all by itself. It's here in column 2. And things that are in column 2 have a +2 charge. Things that are in column 1 have a +1 charge. But this one is in column 2 right here. And it has a +2 charge. So when you're writing a formula, you first get the symbol of the element, and then you write the charge. So the symbol of the element is Ca, and the charge is +2. The second part of this formula is carbonate. That's not off a regular periodic table. It's off of a periodic table that we created here at West Orange High School to help you remember your polyatomic ions. Its root word is carbon, so we find it in the same spot that we would find carbon on a regular periodic table. And we used a color-coded mnemonic tool to memorize this. So this one's blue, and on this chart, if you are blue, you are O3 when you say 8 for your ending. This one's saying 8 at the end, so carbonate is CO3. Now for the charge. The ions off this chart are negative, because the thing that's listed first is positive, and the thing that's listed second is negative. We have a mnemonic tool for remembering this. We know that the bus and the loop all have the same charges, whether they're single elements or if they're polyatomic ions. However, this section of the chart, which in class I have referred to as the annex, has a different set of charges. We remembered that this O looks like a number 0 on the number line. That would make this a number 1, the spot that we're talking about a number 2, and this a number 3 when we learned how to memorize that. So that's a number 2. How are these charges used? Compounds are created out of ions that are put together. That's ionic compounds are. And we determine the number of calciums to carbonate that it takes to make a neutral compound. This has a +2 charge, and this has a -2 charge. So it's only going to be a 1-to-1 ratio. So it's going to take 1 Ca to 1 CO3 to make a neutral compound. So we would describe this as the charges canceling out. So my formula for calcium carbonate would be CaCO3. Now you've determined the formula, then you can determine the mass. To determine the mass, you have to know how many of each of these elements you have. So if you look in the formula, there's no number after calcium, like you see here after oxygen. That's because in chemistry, if we have one of the element, we say the symbols. So this implies you have 1 calcium, you have 1 carbon, and you have 3 oxygens. So we go look on the periodic table for the mass of these substances, and we round them to the closest whole number. So 1 calcium is 40. 1 carbon is 12. And 3 oxygens is 16 times 3. So I've got 40, one of them. I've got 12, one of them. And I have 16, but I have 3 of them. So that's 40 plus 12 plus 48, which is 100. And the units on that are 100 grams per mole. So that's how you would determine the molar mass of calcium carbonate. What's the name and the molar mass of Fe3PO4 with parentheses around it, 2. The first thing you have to do is you have to look up on a periodic table what element is Fe. When I look up on a periodic table the element Fe, I see that its name is iron. So the first name of this substance is iron, I-R-O-N, and it's going to need a Roman number in its name. The way I determine that is by look at the top of the symbol. I see multiple numbers here. That lets me know that iron comes in multiple charges. What charge was this iron determines on the formula that you've been given. To determine that, you look at the numbers that have been provided here. When we write a formula, we crisscross their charges to make a neutral compound. So that means PO4 has a -3 charge, and if that's true, then Fe had a +2 charge. How do you know if PO4 has a -3 charge? You memorized it off your polyatomic oxy-ion chart. This is -1 column, -2 column, -3 column. That's for the bus and the loop. So it does have a -3, which would mean Fe had a +2. That's where I get this Roman number 2 in the name of it, by uncrisscrossing it. Because as I said just a few moments ago, we write formulas to get neutral compounds. So if I were to look at Fe with a +2 charge and looking to pair it up with PO4, which I have memorized to have a -3 charge, if I were to put these two together, I wouldn't get a neutral. I'd get a -1, because a +2 -3 would be a -1. So I would need more Fe's, and Fe is coming in a +2 variety in this particular case. If I had another Fe, I'd have +4 and -3. That would be an overall value of +1. So I'm going to add myself another phosphate, which only come in at a -3 variety. So now I have +4 and -6. So I would need another Fe at +2. Now I have 6 pluses and I have 6 minus charges. That's how come the formula originally that we were trying to solve for was Fe, we have 3 of them, and PO4, we had 2 of them, because you needed 3 of them to balance out the 2 of them. So we, in knowing how the formula is written, can uncrisscross, because to write the formula we would have said Fe plus 2, PO4 minus 3, and they simply get crisscrossed to create that neutral compound. That's where Fe gets the 3 and PO4 gets the 2. And we have to put that in parentheses so we let the reader know we have 2 packages of PO4. So back to that's how I know how to undo it. Back to our formula writing. What is PO4? Well, PO4 is off our polyatomic oxy-ion chart, and we memorize that that is a phosphate. Okay, so now I'm ready to figure out the mass of this. And it's determined the same way I figured out the mass of the last time I had a formula. So Fe, this number is saying I have 3 of them. One of them is 56. So Fe times 3 is 56 times 3. This parentheses with the number on the outside is letting us know we have to do some distributing. This is saying there are 2 P's and 8 O's. So 31 is the mass of 1, and we have 2 of them. 16 is the mass of 1, and we have 8 of them. So when I tally that up, that's 168, that's 62, that's 128. So for a total of 358 grams per mole. That's the molar mass of iron 2 phosphate. That's how that substance would be read. Many of you still don't know your polyatomic oxyions, which are located on this periodic table, as well as 2 other noteworthy ions that you should memorize for Chemistry 1. All of these should have been learned back before the first unit test. If they haven't been learned by now, you need to go ahead and make yourself a set of flashcards that might look like this, where I write an FO3 minus 1 on one side of the chart, and on the other side I write what the name of that is, which is fluorate, and I do it for every one of these elements. It isn't the way I would recommend. I would have recommended memorizing them based on the color coding and where they lie on the periodic table. There is a separate video on memorizing these polyatomic oxyions found on YouTube.